This is problem number 4. Consider the balance or stoichiometry equation. Let me see. It is balance, yes. Um, 40, 44, 16. How many moles of P4S10? So what are they asking for this? And what are they giving you? 2 by 10 to the minus 2 moles of SH. This is 2.0 by 10 to the minus 2. Okay, so it's gonna be, again, we use the stoichiometry, 5 moles of SH, because they're asking for the P4S10. So I put my X underneath and I use my equation, my recipe. 5 moles of sulfur is gonna give me 4 moles. Remember the coefficient, what it means is the moles of molecules or elements. For example, this is a phosphor allotropic, exists at P4, and is one of the allotropes of phosphorus, and it has 4 moles of the molecule, 5 of sulfurate. So 4 moles of P4S10, right? So if I have 2.0 by 10 to the minus 2 moles of SH, how many moles would I obtain? So X, moles and moles cancels out, and X is gonna be 4 moles of P4S10 multiplied by 2, this is a 0, 2.0 by 10 to the minus 2 divided by 5. No units because I already canceled them out. So this is gonna give you, and that's why I had all these prepared, so that way it would be faster. And this is gonna give you 4A. And this is gonna give you 1.6 by 10 to the minus 2 with 2 sig figs. Try it and take it to the right amount, round it to the right amount of sig figs. And this is moles of P4S10. Okay, so let's go next one. If 3 moles, right, let me write this stoichiometry equation. 4P4 plus 5S8 gives me 4 molecules of tetraphosphoro decasulfide. Okay, so now the next question, the letter B, if 3.0 moles of S8 react, how many moles of P4 are consumed? So what are they asking for this one? And this, they're giving it to you, 3.0 moles. Remember that each letter on this type of problems is different. They give you different amount because they want you to practice. If you have this, how much are you going to get? If you have this, how much are you going to get a product? And so on. So you got here 3 moles of S8. Again, let's use our equation first, the top part for the real equation. 4 moles of P4 gives me, it reacts with 1 mole of S8, right? How many moles would I require of P4 to react completely with 3.0 moles of S8? And then you cancel out again, and X would be up and up. And it would be 3 by 4 I think I copied it wrong. Oops. Yeah, I miss a 5 here. Sorry for that, guys. Yeah, I miss a 5. So it's gonna be react with 5 moles of S8. Okay, so it's gonna be 3 by 4 divided by 5. 3 by 4 moles of P4. That's what we're trying to find out. Divided by 5. Again, the units are canceled out. So this gives me, it gives you 2.4 moles of P4 of phosphor. So how many sig figs are they giving us in the problem? They're giving 2 sig figs. So it's already with the 2 sig figs, 2.4. Let's do the next one. And for that, let me put pause. Okay, I just copy and paste the equation. If 124.2 moles of P4S10 are produced, so here you're producing 124.2 moles, right? How many moles of P4 and S8 are consumed? You see that having one, you can find other ones. So which one do you want to do first? Let's start with the one they're asking first for the P4. Okay, so again, I use my recipe, and 4 moles of P4, according to the equation, are going to give me 4 moles of P4S10. How many moles of P4 will give me 124.2 moles of P4S10? So this and this cancels out, and X would be equal to 124. 4 and 4 cancels out, and it's giving you 124, right? Because all of them rest cancels out, zero point 0.2 moles of P4. Now let's go ahead and do the S8. Okay, and the S8 would be, right? S8 would be the same, but you do the cross multiplication again. 5 moles of S8 are gonna give me, if I have 5 moles of S8, they're gonna give me 4 moles of P4S10. How many moles will produce 124.2 moles? Of course, of P4S10. And this cancels out the units again. We cross multiply would be 5 moles of S8 multiplied by 124.2 divided by 4. And this is gonna give me 155.2 moles of S8. And now if you remember, this is the amount they gave us initially in the data, 124.2. On this letter, the question C, letter C. So we have to have it in 3 sig figs. I already put it in 3 sig figs. Just always, see, every time I finish it, even if I did it directly, I always mention it because you can't forget it. So you got here, if, let me copy again the equation. So it says if 5.6 by 10 to the minus 3 P4 react, how many moles of acid would be consumed? Okay, So again, the same thing. We're playing around with the equation. 5.6 by 10 to the minus 3 moles of P4. And they're asking how many would it react. So it would be 4 moles of P4. 4 moles of P4, right, are gonna react with 5 moles of S8. If I have 5 point, just how I said, how many would I need, or how many would react completely with 5.6 by 10 to the minus 3 moles of P4, right? How many moles of S8? S8. So this would be equal to 5.6 by 10 to the minus 3. I took it to the right, to the top, multiplied by 5 moles of S8 divided, why? Because I'm taking this to bottom now, divided by 4. And this is gonna give you 155. No, I'm sorry. We're on letter D already. It's gonna give you 7. Oh, I think, hold on. It's gonna be that I need to calculate because I forgot to put the exponential. I think it's minus 3. 7.0 by 10 to the minus 3, but let me double check. It would be 5.6 5.6 multiplied by 5 divided by 4. Yes, it's 7.0 by 10 to the minus 3. By 10 to the minus 3 to the minus third, or to the negative 3 also facing. Number 5. Calculate the number of moles of CO2 produced when 1.5 moles of hexane molecules, be careful, moles of hexane molecule, they're giving you the moles of molecule, burn inert air by air in this reaction. 12 carbon, 24 hydrogen, 28, sorry, 19 by 2, 38. So it's 24 plus 14, 38. Okay, it's balanced. You see that I check it out? Even though I know it, that it's balanced, which are balanced or not. 1.5 moles of hexane. This is the hexane, C6H14. 1.5 moles. And they're asking to calculate the number of moles of CO2. A piece of cake. Moles of C6H14 hexane gives me 12 moles of CO2. So if you have, instead of 2, you have 1.5 moles of C6H14, how many would you obtain of carbon dioxide, CO2? So it's going to be X, again, cross multiply, 12. Again, this and this cancels out. So 12 by 1.5 divided by 2. And this would be moles of CO2. I forgot to put it before. So this number is going to give you 1.5. But let me double check. No, 9. 9.0 moles of CO2. Here it is. I didn't find 9.0 moles of CO2. Why is it that I put 9.0 and not 9? Well, because we need it in two sig figs. And if you look again, you're giving us two sig figs in the problem. Okay, let's go with part B. Okay, if only, right, 7.5 moles of CO2 were recovered from burning 1.5 moles of hexane, what would be the percentage of theoretical yield for this reaction? What factors might explain the yield being less than ideal, less than 100? Okay, so they're giving you, how do you know they're giving you the actual yield? This is the actual yield because I usually give it in the problem. Actual yield. If they don't give it to you by any reason, they should give you the percentage of yield. So you got here, right? It was 9 moles. You can do it in moles. It gives you a different result. And I did it in moles and it gave me 83%. Let me double check something for a second. Where's the problem? Yeah, the best way is to do it with gram. But yes, you can do it in moles. The most important thing is that when you're doing the percentage of yield, right? When you're doing the percentage of yield, it's the actual divided by theoretical, right? Because it's giving you an idea how much you got after the experiment. Theoretical. Now by 100. But now, if you use here moles, you have to use down moles. Don't forget that. If you're using grams, you have to use down grams. So let's keep on make it easy and use moles. Okay, so they're giving you that the actual yield is 7.5 moles. And in the part A, we got that the theoretical yield, we were supposed to get 9 according to our calculation. Experimentally, we got only 7.5. And by the way, it's 9.0, right? Yeah. By 100, that gives me 83.33%. How many sig figs the problem had initially? 1.5, 2 sig figs. You see 2 sig figs in all the problem. So it's going to be 2 sig figs. So this would be the percentage of yield would be equal to 83%. And that's your result for this problem. Let's go with problem number 6. Calculate ammonia burns in oxygen according to this equation. Let's check if it's balanced. 4 nitrogen, 3 oxygen by 2, 6, 6, 12 hydrogen, 12 hydrogen. I knew it was, but I am just creating a habit for you guys. So this is number 6. Ammonia burns in oxygen according to the reaction. Okay, because I stapled it wrong, I need to have the results handy so I don't waste time on the calculations. 4 moles of ammonia, right, react with 3O2. That's my recipe. Giving 2 moles of nitrogen, that should be nitrogen gas, plus 6 moles of water. Calculate, and this is gas, and gas. Calculate, you don't need to know it now for these calculations. Calculate the number of moles of water. So they're asking me for part A, moles of H2O. Produce in, in the combustion is every reaction that it's added oxygen when you have an oxygen here. NH3. So we know it's going to be 3 grams. Let's write it here so we can do our little it's going to be 4 moles of ammonia plus 3 moles of oxygen react to produce the combustion to produce 2 moles of nitrogen plus 6 moles of H2O. So you got 1 gram. Oh, we started already to work with gram. So what's the first thing we're going to do? Find out the molar masses. I'm going to go ahead and do it here. Okay? So the molar mass, we're going to need the molar mass of of every element and compound involved. So let's find first ammonia. And ammonia is going to be, I did it here on my calculation, 17. Ammonia is 1 by 14.0067, that's the nitrogen, grams per mole, plus 3 times the hydrogen, which is 1.0079 grams per mole. So ammonia is going to give you 17.03 grams per mole. Okay, then we have oxygen, O2 would be twice 15.9994, and that gives you exactly, I think I didn't do it, it's 31 point something. I almost know it by memory. It's going to be 31.9988. 31.9988, 9988 grams per mole. And nitrogen and 2, water. I know it already. Do your calculation, but I know it. It's 18.015 grams per mole. And finally, let me put it in a box each one. And finally, so, and finally, we got nitrogen 2, nitrogen gas N2 would be twice 14.006. That's going to be 28.0134. Okay, grams per mole. So now we got those molar mass ready to start. Please don't forget to do that. It's going to save you so much trouble, believe me. Okay, so now we got 1 gram of ammonia. Calculate the number of moles of water that it's going to produce in the combustion of one. So let's now immediately calculate the moles of ammonia. We were doing everything with mole until now. Now we're starting to work with grams, right? But immediately we have to convert it to moles again. 17.03 grams per mole, and this is 1.00 grams. And if you want to see it written a different way, let me show you. Again, to get rid of the units, you put 1.00 grams. How do you get rid of the unit when it's smaller mass? Well, if it's the unit would be, you have to have moles on top. And remember, this is grams per mole, so it would be 1 mole. So you divide by the molar mass. 17, that's the molar mass of ammonia per gram, mole per gram. So it's going to be 0.05871. I'm going to keep the decimals. 0.05871. moles. Enough. When you're doing the problem, yeah. When you're doing empirical, no, save them all you can. So this is going to be the number of moles. So if you look at your little equation, they're asking for what? We look at our equation. How many moles of water are going to be produced? So this is the one that has the X. And what would be the ammonia? Ammonia, 0.058719 moles. Okay. So again, we use our recipe to calculate the moles of water that we need to produce, that we're going to produce with this amount. See, instead of having 4 moles of ammonia, we had 0.05871. So you would expect that instead of getting 6 moles of water, you're going to get a lower amount of water. 4 moles of ammonia are going to produce 6 moles of water. How many, if you have 0.7819 moles of ammonia, how many moles of water are you going to produce? So again, X would be 0.058719 multiplied by 6 moles of H2O divided by 4. And this is going to give you equal to 0.0881 moles 8808. That's what it initially. No, because I want to take it to the right amount. Moles of Sigfix, moles of water. So if we take it to the right amount of Sigfix, they're giving us 3. So you have to give it in 3. 1.00 gram. That was the data given, remember? So it's going to be 0.0881 moles of water. And that's what they're asking for, right? Let me see if they're asking in grams. No, they're asking just for the number of moles. Do you see? Let's do part B of this problem. How many grams of O2? Now they're asking for grams of O2. So let's copy and paste our little equation. So they're asking for the grams of oxygen that you need. Oops, I got the wrong equation. Let me put a pause so I don't waste time of the video. Okay, so how many grams, they're asking for the grams of O2 are required for the complete reaction of 13.7 moles of ammonia. So they're giving you the ammonia, right? As you cannot get the grams, the first thing you're gonna do, how I said, work it in moles. So with 13.7 moles of ammonia, right? How many oxygen are you gonna get? But you're gonna get it in moles, and you'll see. 4 moles of ammonia will produce 3 moles of oxygen. 13.7 moles of ammonia. How many moles of oxygen is going to give me? You see, we're talking in the same language. We're speaking English and the language of moles, stoichiometry, and the language of a chemical equation. So now we do X equals 13.7 moles. Again, sorry. So it's going to be 13.7 multiply by 3 moles of oxygen divided by 4, because I already got rid of the moles of ammonia, and this is gonna give you 10.275. 10.275 moles of O2. Now, one of the commons a mistake. Oh, I got the moles. Now I forgot to get the grams. They're asking for gram. Don't forget. Don't get lost. What do you have to do to calculate the grams of oxygen divided by the molar mass of O2? Now, see, that's why a lot of students get confused, and that's why I'd rather have you do it at the beginning of the problem, because what is going to happen? Some of my students, what they do is multiply by 15.9994. Now you already got it with all your calm and with your head clear before you started that you were going to need O2. So it's 31.9988. So we go ahead and plug it in here, right? So we got that the grams would be, oh no, that's the other one. That the grams of oxygen would be the moles by 31.9988 grams per mole, because this is the molar mass of O2, you see? And then we get rid of the moles here, sorry, and it gives you, it gives you grams. Moles and moles. And the answer is gonna be 328, 328.788 grams of O2. Now look at this. How many sig figs? 3 sig figs needs to be 3 sig figs, right? So it's gonna be, to do 3 figs, we have to drop all this. Whoops, that was awful. 3. So it's gonna be 329 grams of O2. And that's your answer. Now again, I'm gonna stop this video because I think that's for number 6. Yeah, to start number 7 on the next one, on video part 3. So you can start having all this.